All right, noble gas notation for electron configuration. So essentially this lesson is showing you a shortcut way to do electron configuration. So here we go. So remember last time we found the number of electrons, we filled our orbital diagram, and then we took that information and made it into our electron configuration. So this way, or today, the shortcut way, we are going to use our periodic table in order to figure out our electron configuration. So this colored picture over here, I recommend doing some kind of notes on your periodic table to remember this pattern, okay? I would not color the different colors, but maybe up here I would put 1s, 2s, 2p, 3s, 3p, 4s, and then kind of make a box and say this one's 3D. Okay, I would do something more like that than I would coloring it, because we're going to color our periodic table in a different way. Anyway, so when we are reading our periodic table, it actually tells us the electron configuration just because of the pattern of the periodic table. So when I read the periodic table, right, if I start over here, I have 1 electron, and then I have 2 electrons, and then this atom has 3 electrons, and then 4 electrons, right? So we're actually adding in an electron every time we move a space on the periodic table. And because of that, we can actually just use our periodic table instead of having to fill in our electron diagram, or sorry, our orbital diagram every time. So we're going to walk through a couple of examples, and then what I'm going to show you is that there's an even shorter way than just reading the periodic table. So we're going to start off by writing the electron configuration for neon. Okay, and I put in a little box right here. This is neon right here on the periodic table, and I'm just going to count. So I'm going to say, well, I know I have to start at 1s, and in 1s I have 1 electron, 2 electrons. And then in 2s, because that's my next one, I have 1 electron, 2 electrons in 2s. And then in my 2p, I have 1, 2, 3, 4, 5, 6 electrons. So my electron configuration for neon is 1s2, 2s2, 2p6. Let's do the same thing now for phosphorus. So phosphorus is, I'm going to do this in purple. So phosphorus is right here on the periodic table. And I'm going to go through the same process. I have to start at the upper left and then work my way left to right and then down. So I have 1s and I have 1, 2. 2s, 1, 2. 2p, 1, 2, 3, 4, 5, 6. 3s, 1, 2. And 3p, 1, 2, 3. So my electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Okay, and what you notice, or what I'm going to have you notice, is that this section of the electron configuration for both of these is exactly the same because they fill in the same order. So we are going to do noble gas notation, where instead of writing all of this out, I can actually just write that piece as my noble gas in brackets. So, oops, actually I will just write it over here. I thought that one was different. Okay, so instead of writing out 1s2, 2s2, 2p6, I'm going to say, well, neon has all that same electron configuration, and the only difference is 3s2, 3p3. Okay, this only works for noble gases. So down here, if we look at our periodic table, and this is something you could color in and label, these ones are the noble gases. I can only put a noble gas in the brackets, and that's just the rule. So if I want to write the electron configuration for calcium, which is right here, and I'm going to do using the noble gas notation, then I'm going to say, well, what noble gas is a row above and at the end? Well, it's argon. So I can say, well, the first part of this electron configuration is the exact same as argon. And then I have 1s, 2s, 3s, 4s. So I'm now in the 4s energy level and sublevel. And I have 2 electrons, 4s2, 1, 2. So my electron configuration for calcium using the noble gas notation is brackets argon 4s2.